All right, today we're going to look at rational inequalities, solving rational inequalities. So the first thing we want to do, well, here's an example of a rational inequality. We've got 3x times the quantity x minus 4 over x plus 3 times x minus 2. So, and that's less than or equal to 0, or sorry, less than 0. So what this means, if it's less than 0, is that this thing over here is negative. So let's write that down. Whoops, I wanted a pen. So this thing over here is going to be negative. And there are two ways that you can have that. You could have the top be negative and the bottom be positive, or you could have the bottom be negative and the top be positive. If you had positive positive, that wouldn't work because then this whole quantity would end up being positive. Same thing if you had negative over negative, that would be positive as well, so that would make this false. So here's what we want to do. We want to look at each 0 on top and bottom. Because if we put 0 in, we're going to end up with 0 on the top, and that's not going to be less than 0. And we put 4 in, we're going to end up with 0 on the top, and that's not going to be less than 0. If we put negative 3 in, we're going to have 0 on the bottom, and it's going to be undefined. And if we put 2 in, we're going to end up with 0 on the bottom, and it's also going to be undefined. So we just want to make these kind of our key points. So I'm just going to draw a number line and just kind of make a mark at 0, at 4, at negative 3, and at positive 2. So do the same in your notebook. Okay, so now what we want to do, we really have 1, 2, 3, 4, 5 key points, or 5 different sections. And we're going to test a number in each of those sections and determine if it ends up being negative, so less than 0, or if it ends up being positive, which would be greater than 0. So let's look at this. What I have, I've got a little shrunk down version of our rational inequality or a rational expression. And so let's just test a number in this area. So if we put negative 10 in, 3 times negative 10, that's going to be a negative. So I'm just going to write negative here. And then times negative 10 minus 4, that's also going to be negative. That's going to be negative 14. And then if I do negative 10 plus 3, that's going to be negative. That's negative 7. And then negative 10 minus 2 is negative 12. That's also negative. So on top we have negative times negative, which ends up being positive, and negative times negative, which ends up being positive. So positive over positive is positive. So this is not what we're looking for. We wanted this to be negative, so we'll just kind of put a little sad face. We don't want, this section's bad. Okay, so let's do the same thing for each other section. So I'll bring this little rational expression over, and let's test it out. So I want to pick one of these numbers in between 0 and negative 3. And I'll switch up colors here. So if I put negative 1 in, 3 times negative 1, that's negative. Negative 1 minus 4, that's negative 5. So that's negative. Negative 1 plus 3, that's positive 2. So that's going to be positive. And negative 1 minus 2 is negative 3. That's negative. So on top we have negative times negative is positive. And on bottom, negative times positive is negative. So positive over negative ends up being negative for this section, which is good. Okay, let's test the next section. And I'm going to get rid of this so it doesn't confuse us. Okay, so number between 0 and 2, I would use 1. And you could use decimals, so if you wanted to do 1.2, that'd be fine. 3 times 1 is 3, so that's positive. 1 minus 4 is negative 3, that's negative. 1 plus 3 is 4, that's positive. And 1 minus 2 is negative 1, which is negative. So we end up with a negative over a negative, which ends up being positive, which is not what we're looking for. Okay, and then we'll test the next section. And once again, I'll get rid of our little markings from the previous one. We're a little cramped. So we'll use 3. That's between 2 and 4. 3 times 3 is positive 9. 3 minus 4 is negative 1. 3 plus 3 is 6, so positive 6. And 3 minus 2 is positive 1. So on top we end up with a negative. On bottom we end up with a positive. Negative divided by positive ends up being negative, which is what we're looking for. So that's good. And then lastly, our fifth section, we're going to test a number over here, and you can pick any number you want. I'll choose, I don't know, I'll just do 7. So 3 times 7 is positive 21. 7 minus 4 is positive 3. 7 plus 3 is positive 10. And 7 minus 2 is positive 5. So we get positive over positive is positive, and that is not what we're looking for. So the only sections that work are this section between 2 and 4, and this section between negative 3 and 0. So our solution to this, I'll do this one in green, is negative 3 is less than x is less than 0, or, what was the other one? Between 2 and 4, so 2 is less than x is less than 4. And so this would be all the answers that would work for this rational inequality. Okay, so this one, it was kind of nicely set up for you because everything was nice and factored out, and then you just tested the different sections. So the next one, of course, you're going to find some that are not quite so nicely factored for you. So I'd encourage you to pause it, try this one on your own. You know, do it just like we do for regular equalities. Kind of ignore the greater than sign and solve it, find a common denominator, and then we'll test the key sections once we get everything set up. So I'll do it right now if you didn't pause the video. And so it looks like this thing here will factor, and it factors into x plus 5, x minus 4. So our denominators are going to be x plus 5 times x minus 4. So it looks like we got to multiply this guy by x minus 4. And this one by x plus 5. And remember, we got to do the same thing to top and bottom. We're really just multiplying by 1, which shouldn't affect the fraction at all. It's just a really nice way of multiplying by 1. Okay, so on the top, or on the bottom, we got a common denominator now. So on the top here, we're going to FOIL it out. Math people call it distributing. So we're going to multiply in, so it'd be 2x squared times 1x, or sorry, plus 1x, plus 10x, and then plus 5, all over x plus 5 times x minus 4, minus, and then we'll FOIL this, so x squared minus 4x plus 3x minus 12 all over x plus 5, x minus 4. And then is greater than 8x plus 14 over x plus 5, x minus 4. Okay, so it looks kind of messy now, but what we'll do is combine like terms, get everything on one side like we have in the past, and then check it with our number line. So 2x squared minus x squared gives us x squared. And now we can subtract these fractions because we do have a common denominator. Let's see, x plus 10x, this ends up being 11x here. And negative 4x plus 3x ends up being negative x. So 11x minus negative x ends up being plus 12x. And then 5 minus negative 12 ends up being plus 17. And that's all over x plus 5, x minus 4. And it's greater than 8x plus 14 over x plus 5, x minus 4. Okay, let me give myself some room down here. So what we want to do, like this is kind of tough to test, when is this greater than this? So I think what we should do is get everything to one side, and then we'll have it greater than 0, and then we can test when is this stuff positive. So what I'm going to do is subtract this fraction from both sides. So I'm going to cheat here. I'm going to go minus, and then I'll use my technology. So I'll just, well, maybe I won't. No, it's not going to work. So we'll subtract this from both sides. So it'll be 8x plus 14 over x plus 5, x minus 4. And then we'd subtract that from here as well. 8x plus 14 over x plus 5, x minus 4. So when we do that, we get 12x minus 8x. That ends up being 4x. And 17 minus 14 ends up being plus 3 over x plus 5, x minus 4. And then what's left over on the right is 0. So we got to figure out when is this greater than 0. So the nice thing about this is the top does factor. It factors into x plus 3, x plus 1. So now we have, oops, that was x plus 1. Let's be a little more careful here. There we go. And then on bottom, x plus 5 over x minus 4 is greater than 0. So when it's greater than 0, like we were saying last time, we want to know when this whole thing is positive. So what we're going to do, we're going to set up our number line, and I'll use my nice line tool here. And we're going to test these key points. So we're going to have a key point at negative 5. We're going to have one at negative 3, have one at negative 1, and one at positive 4. Okay, so let's label those here. So it'd be negative 5, negative 3, negative 1, and 4. So we've got 5 sections again, 1, 2, 3, 4, 5. And we want to test a number in each of those 5 sections to determine if this whole overall thing is positive, which would be good, or if it's negative, which would make this false. So let's test it out. Okay, if we try, let's do negative 10 in this section. This would end up being negative. Negative 10 plus 1 is negative. Negative 10 plus 5 is negative, and negative 10 minus 4 is negative. So negative times negative is positive, and then over positive, so this is going to be positive, which is good. Okay, how about between negative 5 and negative 3? Let's test negative 4. So this ends up being negative 4 plus 3 is negative. Negative 4 plus 1 is negative. Negative 4 plus 5 is positive. It's positive 1. And negative 4 minus 4 is negative 8, so it'd be negative. So negative times negative is positive over negative, which is negative, which is bad. Okay, between negative 3 and negative 1 is, we'll say, negative 2. So this ends up being positive, this ends up being negative, this ends up being positive, and negative. So negative over negative is positive, which is good. And then this section, pick a number between -1 and 4. I'm going to use 0. 0 is a nice one. So 0 plus 3 is positive. 0 plus 1 is positive. 0 plus 5 is positive, and 0 minus 4 is negative. So positive over negative is negative, which is no good. And then lastly, a number above 4. So I don't know, let's do 5. So 5 plus 3 is 8, positive. 5 plus 1 is 6, positive. 5 plus 5 is positive, and 5 minus 4 is positive. Positive over positive is positive, so that's good. So we actually, in this case, we have 3 sections here. And if we kind of shaded this on our number line with, of course, flowers, it would be this section pointing that way. It would be this section in here, and it would be this section going that way. So how we would write that, we'll do that in red off the side, is everything that's less than -5, so x is less than -5, or it's between -3 and -1, so -3 is less than x is less than -1, or everything greater than 4, x is greater than 4. So this would be our solution to this rational inequality. All right, I hope that helps. Best of luck on your homework.